Welcome to the Cell Lab. We are called the Connected Experiences Labs, and as our name indicates, we're all about connecting people to data in the context of the industrial internet, where we have a lot of devices, sensors on all our engines, turbines, transportation, medical equipment, and these sensors are outputting petabytes of data to the cloud. We are a research center that really looks at the human. How do we connect the human to these data? How do we interpret the data, transform it into what we call knowledge, and then from knowledge making decisions? And so we look a lot at the humans, at multimodalities of interactions between humans. We talk with gesture, we use eye contact, facial recognition, speech recognition, head tracking. All these are big chapters in computer science that we can leverage to connect the human to the machine and making the machine look more like a human rather than making the human become like a robotic machine. And the demo I'm going to show you will show some of the gestural interfaces that we create here along with other multimodalities. So this is a platform called the M5, and it's a fancy acronym. It links multiple users in multiple locations, so we'll be talking between two devices. This device can be anywhere on the network, or it could be a handheld device. So multiple users, multiple locations, using multiple devices to look at multiple dimensional information, and I'll show you some of that there in multimodal ways. So let me set up the context. Basically, the context is a utility company, a power utility company came to us and said, we have a big problem. We're paying about $100 to $200 million every year because trees are falling on the power lines. And so when the wind comes, or snow or rain, it breaks a branch or a tree on the power lines. And then you have fires that the company has to pay for. People stop paying their electrical bill. All this amounts to $100 million. So they came, they said, you guys are doing industrial internet work. Use your satellites, your weather station, your sensors to predict where and when the outage will happen in the future. Because what the utility company does today, they just basically passively wait until the electrical current is out, and then they passively correct the damage that already happened. And so with these analytics, we'll be able to predict when and where the outage will happen in the future. And this way we can correct it before even it happens, before the damage occurs. And so in this scenario, we have a supervisor, an operator, a plant operator that is standing in front of a wall of analytics. In this case, we're driving it with these 4 servers. And then on the other hand, you can imagine this triptych as an iPhone, a wearable, a mobile in the hands of the person, the field force agent, in the tree cutting branches or repairing transformer. And so you can see these two are connected, right? So when I change the data here, the data is connecting throughout all these devices at the same time. And so the person in here, so you can start seeing the theme of the M5. We have multiple locations, multiple users, multiple devices. This guy's gonna use multi-touch, and we're going to use gestures. Now, why gestures? Why are we really needing gesture in this context? It's because basically what you're seeing here is only 6 screens driven by these 4 servers. It's a very small wall of analytics for research purposes only. But in the utility company, they had 72 screens. We did user studies there. And so there was about 100 persons in front of them, from police to healthcare folks. The Red Cross was there, journalists, the mayor was there, and they are all observing these data. And so from a user experience standpoint, if I take 100 mice and give it to 100 of people in front of 72 screens, you will end up with 100 mouse cursors on 72 screens. And so you won't know who is really driving this mouse cursor as opposed to this one. You will be completely lost, and it's not natural. And so we're using what we call natural user interfaces to interact with the data. So let me start the tracker. And you can see me typing on several keyboards. And it's because it's our M5 software that takes all these keyboards, basically these machines related to the keyboards, and links them into one virtual machine. And one of them now is doing image processing. So it is recognizing me. So you can see me here on that small screen in green. I just lost a lot of weight because of image processing. And so now the machine knows where my hands are in 3D space. And all I have to do to touch the data is touch an invisible wall in front of me, which we call the ether. And so as you can see, the ether is this invisible space that is in front of every user. This is one of the patents we're waiting on. And so basically it tracks where the user is. So if I go backwards in the scene, the tracker knows where my head is, and then it translates that ether relative to every user. Because you have to imagine this in a huge room with a lot of these sensors. Each sensor tracks a different person. And so if I turn, my ether turns with me, and then it intersects with the ether of the person that is in front of me. And then the interpretation of the gesture is different in the intersection space. And then another property of the ether is that I can put it anywhere, and then I can change the shape of it. There is another ether above me that is like an invisible cloud. And so if I want to bring my data, I can tap into that cloud, and then I can bring the data a little more naturally. So you can see what we focus on is how do we really get the human to interact in natural ways. So we focus on the human and making the machine more like the human rather than making the human like a robotic machine. And so you notice I brought my information here, and they appeared also on the triptych, which is basically a wearable. And in fact, anyone who has an iPhone or a mobile, maybe he's driving down the road, he sees a fire on the power lines, he can take a picture, and all these devices are linked through that Industrial Internet M5 app. So let's talk a little bit about the data and how can we use that data in order to do predictions. So we want to predict when and where the next tree is going to fall on which part of the grid. And so the first thing we need to really look at is the vegetation information, the trees. And so you see here a dynamic heat map that is representing 6 years worth of data, where blue is low values and red are high values of the trees. So basically the satellite shines the radiation on the patch of the Earth, and then depending on the refracted light we can measure the heights of the trees, the density of the foliage. And the reason it's dynamically moving, it's because we're looking at 6 years worth of data. So we know where the trees are and how much leaves there is in them, because if there is a tree that doesn't have leaves or green on it, when the wind comes, there isn't enough resistance or pressure to tip the tree. And so the probability of a tree being broken by a wind when it doesn't have leaves is much lower than when it has leaves. So the input to the classifier or to the neural network, to the analytics, is these 6 years worth of information, and then we add to them 36 other feature vectors. A lot of them are wind related and weather related. So wind direction, wind speed, wind gust, and then rain, hail, snow, storms. So a lot of weather conditions, but then also some static information. Where's the valley? Where's the mountain? What's the shape of the valley? So topology or topography. And then also some electrical information that comes from really the utility company. So you can see here we have these pink lines, about 1 million longitude and latitude of where are the power lines relative to the trees and to the vegetation. And then we have work orders about transformers, electrical information. So all this is an input to the analytics, to the black box, which is the neural network. And then the output are these cones, where the color of the cone, the size of the cone is relative to a number between 0 and 1, where 1 is a high risk of an outage, and 0 is a low risk. So these small cones that are white is low risk of an outage at that particular point. And so what the neural network does is it finds patterns in the data. So for example, it finds that in the last 6 years, every time in this particular valley that has, you know, this elongated shape maybe, when the wind direction is aligned with the principal axis of the valley, and when the velocity is higher than some threshold, when the gust is higher than this other threshold, when the vegetation is higher than this third number, then things start to break. And then it can foresee what is the wind gust and direction and speed and vegetation in the next 3 days. And then it comes up with these cones. And so basically what we've done through collaboration in multiple devices, visualizing the information, we were able to transform 6 years worth of information into what we call knowledge. And I can make a decision here. I can know which team to send, where, at what time, in which order to send these teams, so that they cut the trees before the storm happens in these regions and then cut them in an optimized way. We don't want to cut trees where the storm is not, so that we don't really lose operational value. And so now from this part, we really need now to interact more with the data, because we have a very high level idea. So through this collaboration, we can know where the outage will happen, but my visualization here does not tell me why. It doesn't tell me it's going to happen because a snowstorm is coming tomorrow, or maybe the transformer there is really old, in which case I need to send an electrician with different tools, make different decisions than if I knew that this electrical outage is due to a snowstorm, in which case I make a different decision to send different troops with different tools. So now that we've gotten a global view of the data, we really need to interact more with the data to dig deeper into that neural network and the output of the analytics and get more insights. For this, we're going to go to this different demo. So what we're looking at here is the same data that we were looking at with the big screens, where instead of having cones in 3D, we have them now in 2D. And so this panel here is showing the past 6 years, and this panel over there is showing the future 3 days, the future 72 hours. So basically this shows where the outages happened in the last 6 years, whereas this over there shows where the expected outages will happen the next 72 hours. So future, past. So this is where the data will happen, where the outage happened. This is when. So every single column here is a year, and then every line is a month. So from January to December. So this is like a calendar view where every small square is 1 day. And then the color indicates the outage that happened during that day. And then here we have the input to the analytics. So some of the inputs. We have 36 feature vectors. Here we're showing 7 of them. A lot of them are related to wind speed, wind gust. We have temperature. We have some static information, elevation. So these are the input variables to my neural network. And this one here is a different type of variable called KPI, CHI, customer hour interruption. So if you notice, the coloring in this whole interface is keyed from that particular variable, where basically the red, so if you see a red outage or a red dot here or a red station, that means really it really cost us a lot of time, 80,000 hours, and therefore cost us a lot of money and effort to fix that particular outage. But if you see something gray, black, or maybe whitish, that means probably it's a switch that flipped, and all we did was flipping a switch back to have electricity. So it did not cost us much time and money. And these here are the assets. So we have 81 substations connected to 700 feeder lines down to 300,000 devices, which you will see when I zoom in. And so we have 300,000 devices across 6 years. That's a lot of data. We need to interact with that data, transform it into knowledge again, and then make some decisions. So let's take a use case. So let's suppose I know that tomorrow there is a snowstorm coming up, and I need to make a decision towards where to send my field force agent. Which of these stations is really the most susceptible to snowstorm and freezing cold weather? So I can come to my variables, and you can see all these widgets are related to each other. I can say, okay, for the temperature, show me only these outages that happened when the temperature was 0 degrees or lower. And then you can see this filter that I set is really related to all the other widgets. When I set it to freezing temperatures, you can see that the summer months, June, July, August, are blocked out. So in other words, if you see an outage in the middle of July with the freezing temperature on, that means either you had a very cold summer day, or you have something wrong with your data, which is called veracity of the data. That's a big problem in big data. And so you can give that tool not only to the end user, but also machine learning scientists or data scientists. They can use that to look at their data from polymorphic views and understand it better. So let's continue. So I know that tomorrow, not only it's freezing, but also I'm going to have snow. So I can click on this thumbnail here for snow, and out of 6 years worth of data, I have very few days that had snow and freezing weather at the same time. And a lot of these days are gray or white. And so I can iteratively set as many filters as I want. And so in this case, I'm saying, okay, show me only these outages that cost us a lot of money and a lot of time. And so out of 6 years, I have 7 days only. And then I can set filters in any widget. So here I'm setting it in seasons. So do I want this widget to be here or whatnot? And then from 6 years worth of data from 81 substations, if I set these filters like that, I can see that I'm down to only one substation where we had outages when these weather conditions were there during these times. And so immediately I am able to make a decision to tell my field force agent, don't go here cutting trees, because this is the one that really breaks when you have a storm that has these variables. And so my interaction helped me make a decision in this case. And then I can go down to the level of the devices, and you can see as I zoom in, you can see what we call progressive and semantic rendering. And so we take 300,000 devices and we progressively render them as we zoom in. Very similar technology to what Google uses when they render highway to local streets. And so we take our assets and we use that same technology because this is going to work on a mobile or an iPad. And so as we zoom in here, we can see I am at the device level at about block level. And of course, all of these devices have the same color. And so I cannot really make decisions at this level because they have the same risk of failing. But at a higher level, in this case, I can make, but you can see the technology. So basically, it will help making a decision in this case. So let's use that same technique in the future. So the interactions are exactly the same. The axes are a little bit different. So this is a number between 0 and 1. Instead of looking at CHI, we look at the output of the analytics. So that's a number between 0, meaning low risk of outage, 1 is high risk. And this axis is the same as that axis. This is the probability of the future outage. On the x-axis, we have the time. So these are the next 72 hours. And then these are the same variables input to the analytics. And this is where the outage is supposed to happen in the future. So I can set up with the same technique, I can set up filters. And then I can browse through the data by looking at that in 3 days, the wind value is really low. I don't have wind. The probability of outage is really low. And I'm not expecting any outage to happen in 3 days. But if I go backwards, as the probability here rises, I can narrow down my filter to really very specific events. Maybe I have an important event here. A president is coming to the region. And so I can see every one of these points relate to a different prediction of an outage. So if I hover on the point, it tells me where that prediction is and what is the probability value for it. And as I can go up, I can see it became white right there. I can do the hovering in any of the widgets. So here I see this is where I think most of the probability of an outage happening. This is the biggest circle, the reddest one. And then at this point, I can use the billions of pixels that Google put there on the cloud to literally find a tree in a haystack, so to speak. So I can browse here. I can see this is exactly the tree that, according to my interactions with the data, to the data analytics, I would like the field force agent to cut this exact tree or tree branch. And so basically, you see the point of the demo is to say that using data on the cloud, from Google data, from weather data, from data that goes out of our sensors, we can really detect and optimize our operations and then visualize the data, interact with it to optimize how a factory runs or how a city runs, how a company runs, enterprise, and like that.